Hey, everybody, welcome back to another episode of the Machine Shop Growth Podcast. Your host, Kirk Phelps again. And I wanted to pick up a little bit this week from where we left off last episode regarding AS9100 and some considerations, things you need to think about, things you need to plan before you actually start going down that road for the cert. A couple of reasons people want to go down the AS9100 route. Maybe you already have ISO 9001. You're like, let's just take the leap just in case. Maybe we can just have it there to be ready. Maybe you've got customers and they want you to do aerospace work and you need to start to do it. So you've got work lined up. And then maybe you're just either strategizing, positioning, whatever the case may be, in hopes that you're going to find that additional work. And so each one of those have varying degrees of risk, right? If you're already ISO 9001, going through a little bit of extra effort to get AS90, not a significant risk, right? You're already doing what you're 80%, 100 anyway. So not a major factor to go that additional, I wouldn't even call it a mile. It's an extra quarter mile or so, finish up the aerospace cert. So maybe you have work, right? Significantly lower risk. You're going and getting the cert, you're maintaining this quality system for the work to follow. And then maybe you're doing it as a strategic thing and you're putting, we call it 20, 25 grand out to get this cert and get this up and moving. Now, the price tag I just said is assuming that you're working with a consultant, building your building quality system and everything else like that with a consultant, plus your audit. An audit's not free. You're looking at 3 to 5 grand to get an audit. Working with a consultant to help build your quality system, it helps, right? It helps streamline your process. Now, I know there's some systems out there that people say, I buy this system and look at me, I'm AS9100 certified. Not true. There is no system out there that you can just go buy that gives you all the procedures, all the work instructions, everything else. That's not true. There's still work involved with it. There's still cost involved with it, aside from a system or a software or whatever you use. You cannot buy a software or a system and it come with an AS9100 certification. Because even if it came with every policy and procedure you needed, and if somehow everything were curtailed to your shop or you conform to whatever those boilerplate policies and procedures are, you still have to retrain your people to meet those, and you have to document that you train them and document them on your document training on your new equipment maintenance policies and all these different things. So it's not true. You're going to have some cost associated with getting that cert. And so you just have to go into it knowing, hey, if you do it as a strategic thing, you're going to spend some money in the hopes of getting the return. Now, is it going to be a 1 year ROI, two, three, four? Who knows? Depending on how much aerospace work you can go find or work that you couldn't get before you had that cert, right? So one of the, I would say one of the next things you have to really consider. Last episode, we went over what kind of tooling do you have? What kind of work holding do you have? Do you have the right quality equipment? All those kind of things. We haven't talked about what we're going to start in here is what are you good at? What are you actually going to go for, right? If you're not a titanium or Inconel shop, if you're not used to cutting exotic alloys and things like that's not in your wheelhouse, you don't have any, you're not set up to cut that kind of thing, I would probably not go talk to GE. I'd probably not go talk to Rolls-Royce, right? Because they're making engines. What's an engine made out of? Inconel, high temp alloys, Haynes, Waswilly, that kind of stuff. So probably not in your best interest to target GE for machine parts because the majority of what they have is going to be in that high temp alloy type thing. If you're an aluminum, maybe steel, maybe stainless type shop, we need to be going somewhere that has a higher concentration of those kind of parts rather than going into engine components. So there's a very funny thing here. There was years ago, I was talking with the sales manager for a very renowned ceramic tooling manufacturer. And they mentioned, like, we had talked about maybe starting up a territory up in the Northwest when I was living out in Washington. And I was like, this is a large untapped market for us. There's got to be so much opportunity out there with Boeing and things like that. And the truth of the matter is, you didn't really see a lot of Inconel because Boeing doesn't make engines, right? GE does. GE makes most of the engines that go on Boeing airframes. So there's not really a lot of ceramic out there. Now, come back here to the Midwest, where you have GE right here in Cincinnati. We're cutting some Inconel here. There's a lot of Inconel that gets cut around this area just because this is where they build the engines. Now, most of it probably gets cut at GE, but the fact remains there's more Inconel going on here than there was out there. Just something to think about, just even by locality, right? You might be able to find different things in different areas based on what components they're making of the airframe or air structure, whatever you want to call it, rocket, anything. Yeah. So when we talked about that, what that kind of leads into for me is quoting. Okay. So before, in a non-aerospace machine shop, you're just quoting straight shop rate and burden, put a margin on it, right? And some shops don't even quote with a margin, right? They include their margin into their shop rate. I don't like that. I don't like that at all. When you quote your parts, you should quote with an estimated margin, right? If there's an estimated versus actual, this is what I estimated the job to take. This is what it actually took. So then you can start seeing, I estimated this margin, this is what we actually made. The reason being, you should not be charging a flat across the board margin at all. And so when you start getting into aerospace, that margin is going to become even more variable. And we're gonna go over why. One of the things we talked about in the last episode is your payment terms are going to get extended almost always when you start getting into aerospace work. It costs you money. That cash costs money. They're going to want to increase your margin, right? We're going to want to charge some sort of interest to at least pay the interest on our money, if not pay that interest and pay me interest for sitting on that for 6 months, 4 months, whatever terms agreement you come to with your customer. Your margin is going to be a little bit variable there. Maybe you got a customer on 60 days, 90 days, 120 days, maybe some are 180 days. Who knows? But your margin is going to become variable based on that. And that's just one factor, right? You're going to want to charge a higher margin for more expensive material. If I'm running a piece of 3x3 aluminum, maybe $25, $20, $25, whatever, and I scrap one of those, does it hurt? Sure, any scrap hurts, right? But we're throwing $20 away. While the margin, let me just think how to word this. While the margin percentage might not look as great, right? Because if it's all proportional, if I scrap a $20 piece of material on a part run, it should be roughly the same percentage value as a $5,000 piece of material. That makes sense? If I'm running a $20 piece of material on this PO, the PO value should be that this piece of material is proportional to the value, right? So if I scrap a $5,000 piece of material, this PO value should be so much larger that this material value remains proportional. So the proportion is the same. It's equal. But I can swallow losing $20 over $5,000 much easier, right? So when we get in that $5,000 piece of material, I'm charging a significantly higher margin than I am the $20 piece of material. That's a risk assessment. Okay. That is setting your risk level to your part. This part's a higher risk. I'm going to increase my margin to cover that risk. This part's a lower risk. Hey, I can run this at a lower margin. Capacity, workload. A lot of times shops get busy and they say, I can't quote this. No way. Quote it. So let's just say I'm charging a normal shop rate of 125 an hour, right? And we're slammed, we're busy. I'm going to crank that margin up, and maybe not even crank the margin up at first. Maybe the first route is I'm doubling my shop rate. I'm going to put a little bit of extra money in there to give my guys a bonus or something like that for just working their ass off. Either way, you can increase the margin, you can increase the shop rate. The costs and your burden and things like that don't really change a lot by working overtime. You do have to pay the additional wage on overtime, but either way you want to do it. But fact remains, increase your cost. You're busy. What do you care if they say no, right? You got nothing to lose. You got tons of work to do, right? But if they do want it, make it worth your while. Understand somebody's going to come in here on a Saturday and you need to make it worth it to them, right? If the customer wants something that bad and you're the one they want to do it, they're going to pay for it. Especially if you've already told them like, hey, we're really busy. They said, can you quote this anyway? Yeah. Extend your lead times out. I'm working on that with a customer right now. It's like, we're just so busy that we used to deliver to them because of one of our bigger customers at a 4 to 6 week lead time. And now I'm like, guys, we got to go 8 to 10 weeks because I can't keep putting all of your stuff to the front of the line when there's all this stuff out here that needs to be done. But communicate with your customers ahead of time, right? You can't just let them know that they place the PO. If they're used to business as usual and you're going to make a change, you need to let them know that change is coming ahead of time so they can understand, they can make adjustments within their business model to reflect the changes that you've requested. 9 times out of 10, they're going to be cool with it, right? You let them know ahead of time, you let them know it's coming. Is what it is. Everybody gets busy. If you don't think they do that to their customers, probably wrong because they do it too. We all do. There's times when we can be super accommodating, and there's other times where you got to get in line. And that's the bottom line, really. So there's another factor, right? We're going to adjust our margin for workload capacity. We're going to adjust our margin based on machine. We're going to adjust our margin based on what do we need tooling wise. Or if I'm cutting Inconel, I'm always going to charge a higher margin on Inconel than I am aluminum. Why? Because it's a guarantee I'm going to go through more tooling, cutting Inconel. And anybody that's cut 718 Inconel that's aged to 45 Rockwell knows you can put in 3 different pieces of material from the same heat lot and get 3 different results coming out of that material from your tooling. Don't ask me why. I don't know if it's hard spots, impurities. Maybe you get some through the mix process or whatever, the molten material. Maybe you get some weird deposits, maybe some higher nickel deposits in certain areas. I don't exactly know what it is, but I know that every time I've run Inconel 718, this thing will run great with brand new tools for 3 parts, and then the 4th one, it blows them all up. No understanding of why. It makes no sense. Repeat the same process, runs another part good, and then blows it up again. No clue why, right? But you have to understand those things. We're going to factor our margin. And you need to remember when you quote a part, your margin you're quoting is gross. You're not quoting a net margin. You're not quoting a net profit in your part. Your gross that you're quoting, and the reason we're increasing it is maybe I'm going to quote a 60% gross margin and I'm targeting 25% because some of your COGS and things like that are going to come out of that gross margin. Some of your tooling, different expenses like that to go into this job are going to come out of that gross margin. So when you know you're making something more difficult, you got to bump it up, which this brings me to another point. And this is something that I've always known and understood and thought kept in the back of my mind that this is how I operate, how I organize, but I've never really put it into writing. And so I think this is something that could be valuable to some people. That maybe you haven't, maybe you're trying to figure out, what do I do? What's my first step? How do I know what to go get? Okay. A connection of mine, we were talking about this, honestly, this exact topic. And I said, how do I define what I want to go after? I was like, all right, let's break it into 3 tiers. And Each tier has three categories within it. Three, we'll call them defining factors. Okay. Or tier one is, hey, this is my most ideal type of part that I want to make. Tier two is, yeah, we could do that okay too. Tier three is, we're okay at it, but it's not our favorite thing to do. We want to take those three tiers, and I want 80% of everything I'm quoting to fit into those three tiers. I'm not saying no quote anything that's not in there, but you don't want that to be the majority of what you're doing. You want the majority of what you're doing to be the stuff you want to do and the stuff that you're good at. That's how you're going to make money, right? There's a ton of different descriptive factors that you can do. And the ones I thought of off the top of my head is material type. What material do you want to run? Complexity and quantity. Material type and size. I'll put it that way. So let's say my tier one is aluminum, and I want aluminum to fit into this size of a cube. Why do we define a size? Maybe we're really good at vise work, 6-inch vise, right? So do I want to go quote some 40-inch long, a 20 by 40 part? Sure, I got a 20 by 40 machine, but maybe we shouldn't be doing that. It's at the limit of what we can handle. So you want to quote based on machine capability, tooling capability. Personnel capability doesn't really apply so much yet because this is just about size, right? So our tooling capability, our machine capability, and also our material handling capability. If I don't have overhead cranes, do I want to be quoting 500-pound parts that I got to put in and take out with a forklift? Probably not ideal. If you don't have the capability to handle the material, might not be something you want to mess with. It might not be a good tier one part for you. Tier one, keep in mind, tier one is I'm the best at this. Nobody's faster than me. Nobody's more efficient than me. I know this stuff inside and out. Okay. So we're going to set a material type and we're going to set a volume to the material of what we're comfortable with handling, what we're comfortable with holding. Maybe we don't want to do super deep parts. If you're running a 40 taper or something like that, do you want to be hanging a tool out 4 inches and taking a 4-inch depth of cut, full axial? Probably not. Probably not a good idea. You're going to rip that machine apart, right? So those are the things I'm talking about here. Next one would be complexity. What are you comfortable? What tolerances are you comfortable with holding? Do you want to set a threshold on a quarter radius? I won't do anything with a quarter radius smaller than 130 because I want to use nothing smaller than a 1/4-inch end mill. You can do that. Nobody said you can't. Do I want to set a limit on fillet rads, floor fillets? Do I want to make parts with wire holes? One of the safety wire holes, one of the things in aerospace, big things, you got to drill safety wires. They've always got to be at a 45-degree angle to a square wall. You got to drill through two walls. It's a pain in the ass. Nobody likes doing it. Do you want to do that? Do you want to make parts with ISO ports? Do you want to make parts you have to thread mill? So on and so forth. There's all these different thresholds that you can set on your complexity to tell me, is this a yes, a quote, or a no quote? And then volume. Volume's another. Do you want to make, are you a low volume high mix shop? Or are you a production shop? You got to look inside and you got to decide, what do I want to be making? How many of each part do I want to be making? Okay. So that's just some examples of some subcategories you can put in each tier that kind of help you organize these tiers, these tier structures. So our tier one, I'm the best. Like I said, this is your most competitive tier. I'm going to go at this as hard as possible. I'm going to give the most competitive pricing. I'm not going to really think about it very much because I know I'm good at this, right? I have so much experience with this. I know how to quote it. I know how to get this out the door. I know how to make money on it. I'm in. And you don't even have to really quote it as material, right? There's something like manifolds. Maybe it's a really good manifold shop. So maybe I want to go make aerospace manifolds. Okay. My tier one's manifolds. Maybe I make wing spars. Maybe I make landing gear components. Maybe you're a turbine shop. Maybe you're really good at making turbine blades. Maybe that's your tier one. Whatever the case is, that's what I mean is you can put different subcategories on it to make it more specific on what you're actually targeting. Because if you if you use specificity, target sales, you're going to become more profitable because you're doing what you're good at and not trying to put out fires all the time. Anybody that understands manufacturing knows putting out fires is the fastest way to lose money. Unless I say that tongue in cheek, because if you quote it, you can still make money. It's just, will the market sustain that? Will the market allow you to quote it right enough that you can put out the fire? That's the gamble you take, right? Expedited parts and things like that, you can get away with making the customer pay for it. Quite honestly, it's the inconvenience, it's the tear down, the setup, or the setup, the tear down, the setup again, the overtime cost, all these different factors that it takes to get a part out the door. So expedite, sure. But if it's a not expedite part, if it's a non-expedited part, and it's just something, just a standard lead time part, maybe they've got 10 other people quoting, you're probably not going to beat them, because it's probably one of those other 10 shops is probably somebody that's good at that one thing. So what I'm getting at is, by you trying to win that job, you're probably going to lose money. So you stick to what you're good at for the most part, right? I'm not saying exclusively. So your tier one, again, getting back to the point here, this is what I'm the best at. I kick ass at this all day, every day. I'm going to quote this competitive because I know I can make money at a competitive rate. My tier two, getting back to that variable margin, right? I might add 10, 15, 20% to my margin just to cover any unexpected factors. It's something I'm not as experienced with. I'm not as familiar with. There is a little bit higher of a risk factor here. So maybe I increase that margin a little bit. Tier three, I'm going to increase it even more. Maybe the material's more expensive. Also, maybe there's more complexity to it. So you're going to have more expensive, a higher labor loss if you scrap a part mid-run. And overall, this is just something that we're not as comfortable with. So we're going to bump that margin up even a little bit higher. Now, going back through these tiers, anytime I quote a part, I always add a PITA, pain in the ass factor, right? PITA factor, sorry. PITA, pain in the ass factor. If we get parts that they've got 10 plus or minus 1 tolerances, some tight screw positions, maybe some other real tight GD&T, I'm not going to quote that the same. Let's just take a 1-2-3 block, for example. The 1-2-3 blocks that you buy off MSC or whatever, they've got 12 or 15 holes drilled into 1-inch face. Let's say all those holes are plus or minus 1 with a 3 thou true position, A, B, and C. And then all the holes, the cross holes, all the same boat. That block is going to cost more than the same exact block with a standard plus or minus 5 tolerance across the whole part. You understand why, right? So there's far more risk associated with the tighter tolerance block than the other one. So you have to price that risk into your margin, right? Your margin is what is there to cover some of these whoopses. And we're running 10,000 of those and we scrap 250 going out of your margin, right? Let's just say you quoted at a standard rate. Where's that scrap money coming from? Your bottom line. Okay. So you increase that to cover risk. You complete a risk assessment of the part. You assign it a value based on your PITA factor. I use a 1 to 5 scale based on critical features. 1 is my lowest. It's 1 to 2 or 0 to 2 critical features. 2 to 4, 4 to 6, 6 to 8, 8 plus. We hit 8 plus critical features. That's the highest PITA factor, and go 5% per run, essentially. And that's what I add. PITA 1, there's a 0 additional. We are precision technicians, right? You expect to have 1 to 2 critical features. That's not an additional charge. But when we get to 2 to 4, yeah, I'm bumping up 5%. 4 to 6, I'm going another 5%, and so on, to cover that risk. Because that risk means something. That risk is a cost. And it's not maybe it'll cost you money. It will cost you money. At some point, you will scrap a large amount or large volume of parts. Everybody has done it. Anybody that tells you they haven't, that have been around a while, they will, or they're lying. That's the truth. I've done it. Everybody I know has done it. We don't live in a perfect world. John Bender says on the Breakfast Club, world's an imperfect place, Dick. Bruce fall all the time. It was a little 80s joke for you. Okay, so that's kind of a little bit of an idea on quoting. And why are we talking about this? What does this have to do with aerospace? Speed is key. If you want to land any opportunities in machining for that matter, but primarily in the aerospace world, opportunity waits for no one. If you, there's more times than not, if you're first in line, you win. There's a lot of times, there's a lot of instances I can recall personally. Price meant nothing. When you're working for some of the most wealthy people in the world, the most well-off companies in the world, they don't care about price so much because they need the product. They need it now because we're in a race with another country. The two companies are competing against each other. Blue Origin and SpaceX were racing each other for years between the Falcon Heavy and the New Glenn. Trying to get that thing because why? Contracts. Whoever shows the capability first is going to be leg up on the contract. So these guys don't necessarily care about price, right? Go back to that triangle. Price, lead time, quality. They don't care about price. They want quality. They want lead time. You can have good and fast, but it won't be cheap. You can have fast and good, but it won't have quality. Or, I'm sorry, fast and cheap, but it won't have quality. So they want fast quality. So they'll pay what they've got to pay. So my point in saying that is, again, there are differences out there. If you're going after Boeing parts, those are more of a commodity type market. They care about price. You go into an LTA with them, they're going to want year-over-year cost concessions. You're going to have to factor in escalation clauses, all these different things into a long-term contract with a Boeing, with a GE, with an OEM for commercial aerospace. But if you're going after space exploration and things like that, don't bog yourself down trying to work out every detail or just put your price on it. If you're nervous about it, mark it up a little more. Put another 15, 20 points on it. And send the thing out there. You're going to see enough quotes coming in. And the fact of the matter is, if you're quoting parts and you're winning, I'd say if you're winning over 30, 40%, price is too low. Price is too low. Your lead time is too fast. Your price is too low for your lead time. Something is off. You need to charge more, quite frankly. You should not win more than that. You should be targeting the 30% win rate. Now, sounds crazy because, oh my God, I'm going to waste all this time quoting all these parts, doing all this stuff, and I'm not to get $300,000 out of a million quote. Yeah, probably. But you're not going to waste that much time if you just hang a price on it, send it, get it done. There's softwares out there you can use as well that help you organize bombs, set routing, all those kind of things. AI softwares that can help you quote. But the fact of the matter is, I go back to that point, you start winning over 40% of your quotes, you need to seriously rethink how much you're charging. And again, why I just said this, maybe your price doesn't match your lead time. Time has a cost, right? Quick turnarounds are more valuable than the alternative. So my point is, if you're saying I can deliver in 3 weeks, every time somebody sends you a part, that's worth more money. That's worth more money to your customer. So maybe you're not, maybe your cost isn't wrong. Maybe you're charging the correct cost of $120 an hour, $150 an hour, whatever you want to charge, but it's worth more than that, right? So it's not even necessarily that you read it all the time. You got to know your cost. You got to know your cost, as if every machine shop owner is just some dipshit that doesn't understand how to calculate a cost, right? If you calculate your cost right and you're still winning over 40%, and you're charging a fair margin, all these kind of things, but part of your value prop is I can deliver in 3 weeks, that has value to it. And what you should continue to increase your price to match the market expectation for that lead time. People may not want to do that, but why leave money sitting there on the table? Because it is valuable, right? There is a value to it. Those are the things you have to consider when you get into quoting a part. You have to look at this variable margin thing big time. because no two parts are equal. So you have to quote them accordingly. You have to quote them based on their risk, based on your capabilities, based on your people's capabilities, based on your workload. All these different factors play into how I'm quoting the part, what kind of margin I'm going to charge. Okay. So that gets us a little bit through the quoting part. I think the other thing that we had talked about a little bit in last episode was CMMC and ITAR. There's a lot of, I don't know if I want to call it gossip or whatever about the CMMC requirements. ITAR is number one. You got to be ITAR, period. Because even parts that aren't DoD are going to be subject to ITAR. Parts that we don't want these getting into foreign nationals' hands to have them pirate our work. They don't even have to be things that could fly. There's things that on the ground that are subject to ITAR. Okay. So that's first and foremost. Let's just get that out of the way right now. ITAR, you register through the State Department. You got a POC, some documentation you need. A lot of people see this as just a box to check. Let me tell you, you violate ITAR, it's $1 million fine and or 20 years in prison. Now, that's not to necessarily scare anybody, but that's real. Depending on the sensitivity of your work, you can be working on some very sensitive items. Now, those items are going to be certainly subject to CMMC to protect against cyber attack and things like that, stealing our thing or stuff like that. But as long as you maintain a robust system and you make sure that you're checking your boxes, you get nothing to worry about with ITAR. Just do what you're supposed to do. Do what you say you're going to do, right? Do what you say you're going to do. CMMC side, a lot of the fear being put out there right now regarding CMMC is if you don't get CMMC certified, you're never going to be an aerospace and defense contractor anymore. I disagree with that statement completely because it doesn't even apply to aerospace. It applies to the DoD, right? It doesn't apply to all these other entities. They can say it's going to. They can throw that rumor around all they want. But until somebody puts a pen on paper and makes that a policy, bullshit, right? It's all just conjecture. It's all rumor. Am I saying that CMMC is a terrible thing? No, absolutely not. I think there's certainly places for it. Again, if you're going into some particularly sensitive work, I think it's necessary. But this notion that now you have to be CMMC level 2 to handle CUI, classified uncontrolled information. So unless you're handling CUI, it doesn't really matter. There is a level 1 as well that I think is going to be, if I remember correctly, the level 1 is required for all DoD, or what do you call it, contracts. And because here's the thing, when you start talking about CMMC, and you think about the defense industrial base, you're not talking about just machine shops. You're talking about chemical manufacturers. Look at bullets and things like that to get made, die shops, of course, fab shops, right? But geez, upholsters, your uniforms have oh shoot, I can't remember what the number designator was, but essentially it's a serial number for the item it is. I mean, are those guys all going to have cybersecurity programs in place? Now, the level 1 is from, as I remember reading about it months, at least over a year ago, was a self-assessment, and it doesn't have as many controls as the level 2 does. But the point is, it's something that you should be considering. But again, if you're not in the defense industrial base, right? And I'm not necessarily saying, who cares? Don't ever think about it again. No, you still need to think about it. But again, it's like one of those things. It's like the AS9100 thing. Am I going to go spend, in some instances, $250,000 to get this certification for no reason? If I'm not a defense contractor, what the hell do I care? I don't care. And I'm not going to waste my time or money with it. $250,000 is a hell of a lot of money to ROI. through getting work as a machine shop. You got to think about this. If I'm $1 million a year shop, you think I'm going to go spend 25% of my top line revenue to get a certification I don't need? No, that's stupid. That is financially, strategically irresponsible, idiotic, and insane. Sorry. So if you disagree, I don't know what to tell you. Because quite frankly, at $1 million a year, 25% of your top line revenue, that's probably pushing pretty damn close to your entire bottom line for a year. Nowhere will you ever read, or nowhere will anybody ever recommend reinvesting 100% of your bottom line back into your business in 1 year. Usually it's 30% reinvestment back into the business, right? So you're going to put, if you're, we'll call it 300 grand, you're going to put 100 grand back into it. So maybe it's a 2-year rollout. Maybe your growth strategy is putting 100 grand a year into this CMMC certification. And then at the end of the second year, we're going to start as a defense contractor, whatever. The point I'm trying to make here is if you don't have the work to justify spending $250,000, are you just going to go buy a machine, $250,000 machine, just to sit on your floor? Have no work. Let's just say I'm a mill and lathe shop. I got 5-axis mills. I got mill turns. I got all that stuff. I'm going to go buy a gear hopper. I don't make gears. I don't know anybody that needs gears made. I've never been asked to make a gear in my entire life. I'm going to buy a gear hopper. Does that sound dumb? Sounds dumb to me. I have no leads for gears. I have no opportunities for gears. I've never had an opportunity for a gear, but I'm going to go buy a gear hopper. Oh, better yet, I don't even know how to run a gear hopper. I don't know how to run it. I don't know how to program it. I don't have any tooling for it. I'm just going to buy it. What else am I going to do with 250 grand? Hell with it. Sit on the floor. Doesn't make a lot of sense. Same thing with CMMC. I think there's a lot of hype. There's a lot of fear surrounding it, and it's nothing to be afraid of. It's just another system. Is it expensive? Yeah. Are there cheaper ways to do it? Make it less expensive? Yes. Absolutely there are. Does it have to have a $250,000 price tag? No, it does not. Is it still going to be expensive? Yeah. From what I've been understanding from different auditors and things like that, and a cybersecurity contractor I was working with about a year ago, those audits are $20,000 to $30,000. Now, could it be that I was given bad information? Maybe, but I got to put a budget together somehow, right? Now, let me take a couple steps back. Am I bashing on CMMC? No. Am I bashing on people that are putting the information out there? No. I'm bashing on the ones that are blowing this out of proportion, making it this big deal. It's not. It's not. AS9100 is not a big deal. You're doing your goddamn job. It's that simple. Is it different than what we're used to as a machine shop? Yeah. Yeah, it is a little different, but it's one foot in front of the other. Fact is, the DoD relies on small shops like us. Does it have a huge price tag? Yes. Are they going to, at some point, if they can't get enough shops interested, certified, wanting to deal with this crap, wanting to go down this road, are they going to have to subsidize this cert? Damn right. Otherwise, how are you going to get your parts made? This notion that the only shops that are going to survive are the ones that are CMMC, not true. It's never been true. That's like saying the only shops that are ever going to survive are AS9100. Not true. It's never been true. Right? So I just feel like there's a lot of fear mongering going on around this thing that drives me nuts. I don't like it because the world's not scary, especially the world of manufacturing. This is the most least scary world I think I've ever lived in. Right? And maybe it's just me. Maybe my wife tells me I don't worry about enough stuff. I don't worry about it till it's a problem. She ain't wrong. I don't. I got enough stuff to worry about. And to talk a little bit more about it, yes, it's not cheap. If you are dealing in CUI, you've probably already been notified by your primes that you need to have the certification by a certain date or you'll no longer receive contracts. If you've received that letter, you should have already known before you received that letter that this was coming. And you should have already taken proactive steps to attain certification. Talk to your customers, ask them what's coming down the road. Ask them what you need to be prepared for and make the proper preparations. If you ask them and you ask through all of your customers and everything, and there's nothing put in place, there's nothing the CMMC2 policy affects, what do you have to worry about? Now, if they do, talk to your customer about seeing about getting some sort of cost share on an audit. Maybe they'll subsidize some of your hardware, some of your POAM, things like that. There's options out there. There's grants, right? You can go get state and federal grant money to help offset some of that cost of getting the certification. I'm not saying that it's not, I don't want to call it a big deal, but it's a real thing. It's really happening. But does it affect every single machine shop? Absolutely not. Absolutely not. There's a million other things we make it in this country besides missiles, bombs, and airplane parts. There is. There's there's a ton of things out there that don't require it. So for anybody to tell you, if you're going to get an AS9100, you better be CMMC, not true. It's not true yet. And anybody that tells you it is true is wrong, because there's no policy that's been put out that says any aerospace part you make has to be CMMC level 2 certified. So keep that in mind. It's something to work toward. It's not something that you got to snap your fingers and have done. Quite frankly, it's not something you're going to snap your fingers and have done. This is a long process. It's not something you can just do in 2 weeks. It takes some work. And especially from a machine shop perspective, we're not IT guys. We don't know, most of us don't know how to go spec the correct server, put the firewalls in place, run all the cabling. And quite frankly, why would we? We could be making money instead of costing money. I think that's also part of the hype surrounding it is there's a lot of unknowns because this isn't our wheelhouse, particularly. But I'll be honest with you, it's not my wheelhouse. That's why I was working with a contractor. We're going to hire somebody to do the thing right. Because if I do it, we might go to prison. And I'm not going to risk that. If it ever comes back that, hey, there's something wrong, these guys are the ones that did it. I hired them to do it. If there's some loophole, now granted, your auditor should catch all that, but yeah, I'm absolutely not putting that on me. I'm not saying I did it because I don't know what I'm doing. I'll be the first to admit it. I know my way around a desktop computer, but I'm not an IT guy. And most of the people in a machine shop, owning machine shops, running machine shops, they're not IT, and don't try to be. It's safer that way. Just hire it out. Like I said, I think CMMC is a great thing for the proper applications. We don't all need to be it. We're not all AS9100. We're not even all ISO 9001. It's not an end all be all. It's just a new thing, and it's something exciting to talk about that gets a lot of hype. It's not a big deal. It really isn't. It's only a big deal if you need it or if it's applicable to you. It's not a big deal. So anyway, today we kind of went through quoting, some building we have an ideal customer profile. Maybe we have an ideal part profile, IPP, ideal product profile, whatever you want to call it. We built that. Give you some examples of how to throw that thing together. So you know what to quote, how to quote it, margins, that kind of thing. Talked a little bit about our CMMC, ITAR, things of that nature. This wasn't a CMMC bash session at all. Again, I'll say it again. I think it's a great policy for the appropriate areas. I just think get up every once in a while and be like, does this even apply to me? Because I know there's a lot of people out there that read that stuff and they just get all wound up. And so that's really what I'm trying to do is I'm trying to make sure that those people aren't getting all wound up about this stuff. Because if it doesn't apply to you, it doesn't apply to you. Don't worry about it. Just keep on keeping on. So yeah, anyway, that'll be it for today. I think I'm looking at the next couple episodes. I'm going to bring a few guests on. So I'm sure you guys are tired of hearing me talk the whole time. So we'll get a couple guests on. I got a good friend of mine has got an exciting product for the CNC world that I've been trying to get on for a little while. Our schedules just haven't meshed up. A couple other buddies I want to get on here as well, that they've got a wealth of information for machining worlds. Look forward to that for the next couple of episodes. And Other than that, I will see you all next week. Thanks for listening and have a good one.